In a previous video, you have seen about properties of addition. Now today, you are going to see about properties of subtraction of integers. As addition, subtraction is also having all properties. The first one is a closure property, commutative property, associative property and identity property. So now, let us see one by one. What is a closure property? Closure property. As we discussed in addition, if you add two integers, then the result should be also an integer. Now here in subtraction, if you subtract two integers, means the difference of the integers should also be an integer. So let us check. For example, if a and b are two integers, then a minus b should also be an integer. So example, -1 and 3. If I take these two as integers, so -1 minus 3 equal to -4, which is an integer. So closure property satisfies under subtraction also. Now next property is commutative property. Next property, commutative property. So if you take two integers a and b, then if you change the order of the property, order of the numbers, so a minus b should be equal to b minus a. Is it same, children? No. So this is not equal. A minus b is not equal to b minus a. We will check it once. For example, if I take two integers as 6 and -5. So what is a minus b? 6 minus of -5. That, and b minus a is -5 minus 6. So here this is 6 plus 5 and here it is -5 minus 6 is -11. So 6 plus 5 is 11. 11 is not equal to -11. 11 is not equal to -11. So you can say that a minus b is not equal to b minus a. So in subtraction, commutative property does not holds good. Now the next property is associative property. Next property is associative property. So here you will take three integers. For example, a, b and c are three integer numbers. Then if you change the grouping of the numbers, so a minus b minus c should equal to a minus b minus c. Here also this is not equal. We will check it with an example. Let us take an example. -4, 9 and 2 are the three integer numbers. So now 4 minus 9 minus 2 is not equal to 4 minus, this is -4. I have taken it as -4. So -4 minus 9 minus 2 is not equal to -4 of 9 minus 2. So -4 and -9. -13 minus 2 is not equal to -4 minus 9 minus 2 is 7. So -13 minus 2, it is -15 is not equal to -4 and -7, it is -11. So here a minus b minus c is not equal to a minus b minus c. So in subtraction, commutative property also not hold good. The next property is identity property. So you all know 0 is an identity element. So if you subtract 0 from an integer or an integer from 0, is the result same? Will you check? So 0 minus A is equal to minus A, but whereas A minus 0 is equal to A, where minus A is not equal to A. Therefore, here in subtraction there is no additive identity element. Till now we have seen two operations. One is addition and the other is subtraction. Now let us move to the next operation, multiplication. Here also you have two things to know. Which one is for the like signs and the other is for the unlike signs. We discussed in the addition topic with the like signs how to add and with the unlike signs how to add. Now we will discuss with multiplication how to do with the like signs and how to do with the unlike signs. So plus of plus, plus of plus, minus of minus. These two are like signs. So the resultant will be plus. The resultant will be plus for like signs. So when you are multiplying like sign numbers, means integers, like signed integers, then the resultant will be positive. Whereas in an unlike, means plus of minus or minus of plus, the resultant will be negative. This is for unlike signs. So if you multiply a positive integer with a negative integer or a negative integer with a positive integer, the resultant will be in negative. The result will be in negative. If you multiply the same signs, means like signs, positive integer with a positive integer or a negative integer with a negative integer, the resultant will be positive. So the product of two integers with like signs is positive. The product of two integers with unlike signs is negative. Now we will see about properties of multiplication of integers. The first property, as you all know, it is closure property. So here it is a product. If you find the product of two integers, then the resultant should also be a integer. So A and B are two integers. Then if you multiply A into B, the resultant should also be an integer. For example, if I take minus 2 into 3, the result is minus 6, which is an integer. Even if I take two positive integers, 3 into 3, then it is 9. 9 is also an integer. 9 is also an integer. So closure property holds good in multiplication. Till now you have seen three types of properties. One is addition, subtraction and multiplication. In all the three cases, closure property is satisfied. Now the next property is commutative. If you take two integers, if you interchange the numbers, means if you change the order of the numbers also, the resultant should be same. For example, A and B are integers, then A into B is equal to B into A. Let us check with an example. If I take two integers as 10 and minus 4, so what is the product of 10 and minus 4? 10 into minus 4 is equal to minus 4 into 10. I already told you one positive number with a negative integer, the result is negative. So 10 into minus 4 is minus 40, and whereas minus 4 into 10 is also minus 40. Therefore, commutative property holds good in multiplication. Now coming to associative property. Here you will take three integers. A, B and C are three integers. Then if you change the grouping of the numbers, means A into B into C is equal to A into B into C. Let us check this with an example. If I take integers as 10, -4 and 3. These are the three integers. Now if I multiply, so 10 into -4 into 3 should equal to 10 into -4 into 3. So 10 into -4 is -40 into 3 equal to 10 into -4 into 3 is -12. So 40 into 3 is -120 is equal to 10 into -12 is also -120. Therefore, associative property also holds good in multiplication. Next property is multiplicative identity. Multiplicative identity. In additive identity, I told 0 is an additive identity element. Now, this is multiplicative identity. So, when you multiply an integer with some number, the result should be as the number itself. So, the multiplicative identity is 1. See, A into 1 is equal to 1 into A is equal to A. For example, 5 into 1 equal to 1 into 5 is 5 only. So here you will call 1 as a multiplicative identity. See children, you need to remember here that 0 is an additive identity element, but whereas 1 is a multiplicative identity element. They can ask you the question like this: what is a multiplicative identity element? 1 is a multiplicative identity. 1 is a dash element, multiplicative identity element. Children, you need to remember this. 0 is an additive identity element, but whereas multiplicative identity is 1. Next is multiplicative inverse. Next is multiplicative So the multiplicative inverse of A is 1 by A. Means the product of these two, it should be result as 1. A and A will get cancelled and the result will be 1. For example, if I take the multiplicative inverse as, if I ask you what is the multiplicative inverse of 5? It is 1 by 5. So when you simplify this, you will get answer as 1. If the number is -3, so what is a multiplicative inverse? Into 1 by -3 is a multiplicative inverse. Whereas in addition, you are changing the sign of the number. But here in the multiplicative inverse, you are not going to change the sign of the number. You are writing that number as 1 by. So -3 and -3 will get cancelled here and your result will be 1. Next property is zero property. Next property is zero property. If you multiply an integer with 0 or 0 with an integer, the result is 0. Means 0 into A is equal to A into 0, that equal to 0. For example, -8 into 0 is equal to 0 into -8 equal to 0. So 0 property is if you multiply an integer with 0 or 0 with an integer, the result is 0. And the next one more important property is distributive property. Distributive property. Here you have two things in distributive property. So distributive property of multiplication, over addition and over subtraction. So you have two properties of distributive property. So distributive property of multiplication over addition and distributive property of over subtraction. So if you take three integers a, b and c as three integers, what is distributive property over addition is a into b plus c should equal to a into a. So what is the distributive property over addition? It is a into b plus c equal to a into b plus c into a. Or you can write a into c also. Next is over subtraction. So a comma b comma c are three integers. Then a into b minus c is equal to a into b minus a into c. This is distributive property over subtraction. Now we will check the property of addition first. So for example, if I take three integers as 1, minus 2 and 3. So now 1 into minus 2 plus 3 should be equal to 1 into minus 2 plus 1 into 3. So 1 into minus 2 plus 3 is 1. Here 1 into minus 2 is minus 2 plus 1 into 3 is 3. So 1 into 1 is 1 is equal to minus 2 plus 3 is also 1. So it satisfies distributive property over addition. Now if you take for subtraction, what is the distributive property over subtraction? A into b minus c is equal to a into b minus a into c. Let us take these three numbers itself. 1, minus 2 and 3. So 1 into minus 2 minus 3 should equal to 1 into minus 2 minus 1 into 3. Here 1 into minus 2 minus 3 is minus 5. Minus 2 into 1 into minus 2 is minus 2 minus 1 into 3 is 3. So 1 into minus 5 is minus 5. Minus 2 and minus 3 is also minus 5. So distributive property over addition and subtraction also satisfies in multiplication. Till now we have seen three properties. One is addition properties, subtraction properties and multiplication property. So our next operation is division. Our next operation is division. So division also, as in multiplication, how we did with this like signs and an unlike signs. See, if there are like signs, plus divided by plus, minus divided by minus, these are like signs. So when you divide two positive integers or two negative integers, the resultant will be positive. So these are like signs. When you do it with the unlike signs, positive integer divided by a negative integer and a negative integer divided by a positive integer, then the result will be negative. Unlike signs. So as multiplication, if you in the same manner for the division also, if you divide both the positive integers or both the negative integers, the resultant will be a positive integer. And if you divide an unlike sign integers, a positive integer with a negative integer or a negative integer with a positive integer, the resultant will be negative.